Greetings, 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 greetings. This is I, your king, King Clifford Jefferson, descendant of Godfrey, the fifth kind of band Jew, son of folk, ruler of Jerusalem. I'm the reincarnation of King Edgar the Peaceful, which you call Jesus Christ. I'm here with another marvelous lecture in regards to concerning. Let me just get the title because this is part 3. The Torah, the 5 books of Moses concerning mysticism, mystical, cosmogony, and mystical psychology. All right, this is part 3. All those who are viewing this or will be viewing this lecture, please refer to, okay, once again, please refer to part lecture 1 and lecture 2 before you view this video. All right, so without further ado, let's get started. It is September 26, 2023, which in the Berber year is 2973. I do this lecture on behalf of my ancestors who are of the noble family, going back to what we call time memorial. This is in representation of the image of Christ, as well as the information that Christ gave to his prophets, his teachers, those who were to inform those who were not informed about what it is that they were called to do. All right. Let's get our reference point from what we took off in our last video, which would be 6,000 years. The 6,000 years. I'm going to move quick. I'm going to break this video up in what they call sections, so that way I won't have any problem uploading, as well as that your attention span will not be wavering in regards to what it is I'm trying to get across. All right. I'm going to refer to a couple of videos in regards to the understanding of cosmogony from those who are more experienced in the what they're deemed as being professionals. All right. I don't work for NASA. You know, I don't work for any of those government agencies that were created to deal with the study of interstellar or interspace or the discovery of other galaxies, the universe, etc. You know, I'm only going based off what was decreed according to the information that was provided to us in regards to which I'm using as a reference to Talmud, the Midrash, and the Zohar. We know Talmud means to study, Midrash means to interpret what it is you study, and Zohar means to the understanding of the psychological effects that the universe has on us as being entities made of what we call matter. You know, and as a result of that, the changes that affect the earth affects us. You know, when we would understand the part we play in that great transformation, you know, and we get it from an abstract point of view, but not from a concrete point of view. And that's my aim. So as we can see, the 6,000-year cycle, which we're in now, is completed in the year 5784, which is the year 2023, which we're in now. We'll come to the completion in 2024. All right, in the Berber year, that's 2973 and 2974. You know, the creation story that was established for the creation of, we said this universe was established in 3761, 3761. All right, as we see here. And as we go to the year 1 AD, it clarified it based off what we call the calendar. AD is the Berber year 951, which is the time of King Edgar the Peaceful, who we deemed to be Jesus Christ. And the Hebrew year is 370 3761 AD. All right, 3761 AD. All right, we know that we know the difference between the Gregorian calendar. We know the difference between the Julian calendar, and the difference between the Berber calendar. We know the Berber calendar means before Christ. We know AD means Anno Dominus in the year of our Lord, i.e., the year of the birth of Christ. All right. So we already discussed that in the last video. Those who didn't catch that, please review that. For the sake of time, let's move forward. for all you can see. All right, hold on for 1 second. We know that all these deities of the noble family affluent. We know affluent means noble, and ing means belonging to. All right, so this is the image that I am incarnated or personified or incorporated to represent. All right, we already discussed that. Those who haven't reviewed that information, please review the prior lectures that I've done. The Minister Charter. I don't know why it's not showing up. Give me a second. It's not showing up. It might be my computer. Oh, now they don't want to display the file. All of a sudden now the file can be displayed. I wonder what's going on with that. All right. All those who reviewed the other lessons that I presented, that will be able to be seen. Luminous Charter is an Anglo-Saxon limited manuscript that was likely composed by Bishop Ethelwald, presented to ministers in Winchester by King Edgar in the year 966 AD to commemorate the Benedictine Reform. All right, the Benedictine Reform. And approximately 963, make sure you all see this. In approximately 963 AD, Anastomenius, not BC, Bishop Ethelwald of Winchester required the monks and new ministers under threat of eviction to adopt Benedictine rule. This decision was made with the approval of King Edgar, who reigned in England from 959 until his death in 975. He was born in 943. He came to be king of England in 959 and he died in 975. Okay, and we see the year 180. AD 51 from 959. All right, so all those who want to do a serious inquiry on that, please do so. But for the sake of time, let me move forward. And during the 6,000 year cycle, it says that under the Midrash Talmud, we know that the Talmud means to study. The Midrash means to interpret. We know Zohar means to be able to make sense of the mystical meanings in reference to uh, the psychological effect they have in regard to the interpretation and the study concerning, as we see, the cosmogony. All right, we know cosmogony deals with, as they see in the abstract, the analysis, the belief that the seventh millennium was correspond to the Messiah age is founded upon the universal application of the concept of Shabbat, based on verse Psalms 90, verse 4. One of the God's days believed to correspond to 1,000 years of normal human existence. That's in the Bible. God created the world in 6 days of work and sanctified it the seventh day as a day of rest. So all this deals with metaphors, but the metaphors are no longer applicable because we're going to qualify it with the concrete. All right. We know that cosmogony, as it said, Zohar, Zohar is foundational work in the literature of Jewish mystical thought, known as Kabbalah originally with in Aramaic. It is a group of books including a commentary on the mystical aspects of the Torah, the 5 books of Moses, the scriptural interpretation, as well as the material of mysticism, mythical cosmology, and mystical psychology. The Zohar contains discussions of the nature of God, the origin of the structure of the universe, the nature of the soul's redemption, relationship of ego to darkness, and true self to the light of God. All right, that's our syllabus. That's our synopsis. All right, everybody must understand that. So you can look at it from the abstract or the concrete, because we know that the mystical or the mysticism concerning the universe is what we've been told by other people who are doing research that's not based off mystical research, but based off science. All right, based off the science of the stars, i.e., cosmogony. All right, which we'll review now. So, what is cosmogony as referred to in the Zohar that we must have a study and interpretation of? I reviewed this and talked about this in my last lesson. Please review it. Cosmogony is a model concerning the origin of the cosmos or the universe. Overview. In astronomy, cosmogony refers to the study of the origin of a particular astrophysical object or systems, and most commonly used in reference to the origin of the universe, the solar system, or the Earth, moon, and system. The prevalent cosmological model of the early development of the universe is the Big Bang theory. This is based on gravitational singularity. All right, we see the example here displayed on your right side. The Big Bang theory, which states that the universe originally expanded from high or infinite density, is widely accepted by physics. You know what I'm saying? So it says the Big Bang theory, which states that the universe originally expanded, this talks about universal expansion. The universe expanding. All right? It's expanding. This is what we're going to talk about. Sean M. Carroll, who specializes in theoretical cosmology and field theory, explains two competing explanations for the origin of singularity, which is the center of space in which characteristic is limitless. All right, limitless, i.e., void. All right, void. One example is the singularity of a black hole, where gravity is the characteristic that becomes limitless and infinite. Okay, infinite. So that means there is no matter. It's infinite. Void of matter, which there means there's nothing more than space, i.e., 0 point energy. So you went from matter to antimatter, which we'll discuss in a second. From matter to antimatter. All right. This antimatter goes in what they call what's the term here? Transmission medium. Transmission medium, what they call interstellar medium. Transmission medium, or what they call interstellar medium, which means the space between stars. Interstellar medium means the space between stars. All right. We all know what a star is. All right. We all know what a star is. We'll talk about this in a second. All right. Before we talk about this, we're going to get a reference point from a professional. And while the professional's talking, we're going to stop the video and explain it, because I'm not professionals in this field and what they speak about. but I am a professional in the understanding about what they're talking about, simplified. All right. So I'm simplifying what they're trying to make it seems is so hard to understand. All right. So let's get started. Once we watch the video, we're gonna end it and go into part 2. I mean part 4.
However, there were no distinctive.
I'm going to stop the video when I get to a specific point that I want to raise.
Stars light up our night sky with a romantic luster, but in a dark turn of events, about 700 trillion of our stars have suddenly vanished. As you might expect, scientists were terribly puzzled, but that was only the beginning. New objects are now emerging from deep space that we must also figure out quickly. Who or what is behind the mysterious disappearance of 700 trillion stars in our universe? Is there a...
So they're saying 700 trillion stars just vanished out of nowhere. All right. Something was once visible is not visible anymore. All right. 700 trillion stars have vanished. All right. But something else has took the place of where those stars were. All right. Please pay very close attention to this. All right. This is what they are saying.
Connection between disappearing stars and these unknown objects from deep space. Join us in this video as we delve into the mysterious events unfolding in space as scientists warn that over 700 trillion stars have suddenly vanished with something emerging from the dark. We will unveil the potential reasons behind the vanishing stars and look into the emergency of this unknown.
You see something that looks like a star in an old image, and then you never see it again.
It has taken humanity millennia to grasp concepts like science and mathematics, which aid us in deciphering our role in the universe and the fundamental nature of Earth, even though the core remains shrouded in mystery. One of these foundational principles underscores the idea that matter cannot simply vanish, it must transform. Consider, for instance, an individual vanishing after plunging into molten lava. Vanishing is only the last phase of the scientific event. The matter undergoes a profound alteration before transitioning into a different form. Similarly, when a star explodes and disappears, its constituent matter scatters throughout the cosmos, enduring in an alternate form. We bring up this point because a baffling enigma has surfaced in the depths of outer space, one that currently lacks a definitive solution: the disappearance of stars from our night sky.
Okay. So you just heard him say that matter cannot be destroyed. We know energy cannot be destroyed. That brings on what we call zero energy, what's called energy matter equivalence, or what we call special theory of relativity. E equals mc squared. Energy in matter is constant to the speed of light. This is what they just said. All right. This is what they just said. Even though we know matter can incinerate, it can burn, it can go through the combustible stages, there's something still there. All right? There's something still there. We know that our universe is composed of what we call matter. All right, it's composed of what we call matter. But within the system, for what we perceive as matter, there's something that they call dark matter. Dark matter. All right, what is this dark matter? This dark matter is void of any density of what we call matter. So this matter that's void of density, i.e. matter, is called antimatter. All right, antimatter. This is used as what we call an interstellar medium, as a transmission medium for signals and waves. We know light travels through black holes. Light travels through black holes. Nothing can escape a black hole because of the gravitational pull of a black hole.
At first glance, this might not strike as particularly remarkable, given the vast expanse of the universe, where the abrupt disappearance of a star can be attributed to various factors, such as reaching the culmination of its life cycle or succumbing to the gravitational pull of a colossal entity like a black hole.
Okay.
However, what makes this situation bewildering is that the vanishing stars are not isolated occurrences. They are numerous, numbering in the trillions. Recent measurements indicate that more than 700 trillion stars have inexplicably gone missing, leaving astronomers bewildered as to how they could have abruptly blinked out of existence. While the disappearance of a few stars can be accounted for in a universe of such scale, the vanishing of hundreds, especially those not nearing the end of their life cycles or threatened by external forces, presents an entirely different problem. Fortunately, some dedicated scientists are diligently working to unravel this cosmic mystery. Beatrice Villaroel of the Nordic Institute for Theoretical Physics in Sweden sheds light on their efforts, saying, "VASCO, or the Vanishing and Appearing Sources During a Century of Observations project, is our endeavor." She further says, "We are intrigued by various vanishing objects, but our ideal pursuit is to identify a star that has maintained a constant presence in the sky for as long as human memory and available data can recall, only to vanish without a trace suddenly. Even the most advanced telescopes fail to reveal any remnants." It is essential to recognize that this isn't merely a whimsical pursuit. The VASCO project has been active since 2017 and has garnered considerable attention. Villaroel elaborates that the project has garnered interest from astronomers across diverse fields, including experts in active galactic nuclei, stellar physics, and SETI scientists, each driven by their unique motivations to participate. The team acknowledges that certain aspects of the universe remain unpredictable, given our limited ability to catalog every celestial object with absolute precision due to vast distances. Nevertheless, they maintain confidence that discovering a specific type of star suddenly disappearing from the sky could yield groundbreaking insights. Villaroel emphasizes this potential that while they understand the existence of variable stars, their changes typically occur over a few years at most. The quest is to locate a star that transitions from unwavering stability to complete disappearance, a phenomenon that has not yet been documented. Such a discovery has the potential to unveil new realms of physics. Perhaps you're wondering, is it truly possible for a star to simply vanish without warning? The answer is yes. For instance,
Okay, you say yes, and let's prove it. Why? Let's prove why that stars can only be studied based off the existence of a star. We know a star is what we call a planetary nebula. All right, a planetary nebula is what we call a molecular cloud. It's called a molecular cloud, and the closest one to Earth is called the Helix Eye. All right, it's called the Helix Nebula. Let's check it out. We're gonna come back to this video. Everybody see this? The Helix Nebula is a planetary nebula located in the constellation of Aquarius. We know Aquarius is between the constellation of Capricornus and Pisces. My sign is Capricorn. All right, we know Pisces represents the fish. We know Aquarius means water. So we know that's a representation of what we call birth. All right, birth. All right, in planetary nebula located in the constellation of Aquarius, discovered by Carl Harding, most likely before 1824. This object is one of the closest of all the bright planetary nebulas on Earth. All right, It said it's the closest of all the bright planetary nebulas on Earth. All right, we must understand that. The Helix Nebula has sometimes been referred to as the Eye of God, as well as the Eye of Sauron. And we all watch The Hobbits or The Lords of the Ring, the Eye of Sauron. This is what they're talking about, but it's been referenced as the Eye of God. The Helix Nebula is an example for a planetary nebula. What is a nebula? A nebula, cloud, or fall in Latin, nebula, nebulae, or nebulous, is a distinct luminescent part of an interstellar medium, i.e., luminous ether. All right, we'll talk about that in a second because the origin of the nebula goes into that, which can consist of ionized neutral and molecular hydrogen, and also cosmic dust. The nebulae are often star-forming regions such as the pillars of creation. All right, such as the pillars of creation and the Eagle Eye Nebula. In these regions, the formation of gas, dust, and other materials clump together to form denser regions which attract further matter and eventually becomes dense enough to form stars. This is a result of what we call gravitation. This goes into what we call general special relativity. General relativity theory. You have special relativity theory and general relativity theory. All right. Albert Einstein discussed them both. So the closest nebula or planetary nebula to us, which is nothing but a cloud, which is the luminescent part of an interstellar medium. And interstellar medium is what we call a molecular cloud. All right, it's a molecular cloud. And we know that suns are born from this. All right. We know when the Big Bang explodes, the Big Bang explodes, and all that's made with contained as a result of that explosion spans out to what we call the universe. It's called the universe expansion. It's called the Big Bang. All right, and the Helix Nebula is one. All right, that's one of examples of a Big Bang. All right, let's just get a little understanding about that before we go back into the video.
Greetings and welcome to the introduction to astronomy. One of the things that I like to do in each of
Excuse me. I'm trying to stretch the screen out.
Greetings and welcome to the introduction to astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website that is apod.nasa.gov/apod. And today's picture for August the 23rd of 2020.
Forgive me, let me start this over again.
Greetings and welcome to the introduction to astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website that is apod.nasa.gov/apod. And today's picture for August the 23rd of 2020, well, it is titled The Helix Nebula from Blanco and Hubble.
Telescope,
so
y'all.
what do we see here? Well, this is the planetary nebula known as the Helix Nebula. And a planetary nebula is what occurs at the end of the life of a
It's a
star,
star.
much like our own sun. And what happens when a star reaches the end of its life is that the core compacts down to a very dense object called a white dwarf at the center of the helix here, and the outer layers are expelled out into space. So the core ends up being a very compact object, extremely massive
Hold
still,
on.
but compressed down to about the size.
Video's not showing right. Let me stop this and go back. Okay, let's try this again. Forgive me, y'all. All right.
Greetings and welcome to the
Let's try this
introduction
again.
to astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website that is apod.nasa.gov/apod. And today's picture for August the 23rd of 2020, well, it is titled The Helix Nebula from Blanco and Hubble. So what do we see here? Well, this is the planetary nebula known as the Helix Nebula. And a planetary nebula is what occurs at the end of the life of a star, much like our own sun. And what happens when a
Okay, so planetary nebula is what occurs at the end of the life of a sun. And we know a sun is a star. All right. We know in this solar system or universe, it's up to the gravitational pull of what we call the sun. All right. But this sun resulted from a Big Bang effect. All right. From a Big Bang effect, a black hole. Part itself, not a black hole. The Big Bang effect was a result of what we call, as they said, the creation of so much force of energy compiled together. So it says our sun, as we see now, the end result of a sun will result in what we call a planetary nebula, all right, which is what we call a collapse of the gravitational pull. Once again, a collapse of the gravitational pull. We'll discuss that in a second. Let's continue to watch the video.
star reaches the end of its life is that the core compacts down to a very dense object called a white dwarf at the center of the helix here, and the outer layers are expelled out into space. So the core ends up being a very compact object, extremely massive still, but compressed down to about the size of the Earth. The remaining material in the outer layers are then expelled out into space, and because that white dwarf star is so hot, it energizes and excites all the gases and causes them to glow for a short time, maybe only 10,000 years or a few tens of thousands of years or so. So it's a relatively short period of a star's life at the very end. Eventually, all that will be left behind is the white dwarf star itself. Now, one of the things that's interesting to study is that planetary nebulae come in a wide variety of shapes. So, how did something like this form from a single star, a single ordinary star? So, this could be something like what our sun will look like in 5-6 billion years or so when it ends its life. We see not just the helix with the spirals, but we do see a couple of different disks that are perpendicular to each other, as well as all sorts of other features within this that are very hard to explain from just a single star. Now, we do know, of course, that it happened because we can see that it exists here, but understanding exactly why it happens is still a topic of research by astronomers to try to understand how things like this can form. So astronomers look at all sorts of planetary nebulae, and in this case, looking at it with two objects, the Hubble Space Telescope up in orbit above the Earth, and a telescope down in Chile, about 4 meters in size, known as the Blanco Telescope. So looking at those two and able to put all of that information together helps us to understand a little better maybe what will happen at the end of the life of our own sun. So not something that we know for sure. And looking at different planetary nebula, we don't completely understand that process yet. We can see what happens, but we don't understand exactly what goes into it and what happens within the star that causes all of the different shapes of planetary nebulae that we see. So that was our picture of the day for August the 23rd of 2020. It was titled The Helix Nebula from Blanco and Hubble. We'll be back again tomorrow for the next picture, previewed to be a rounder.
Okay, so as you can see, the Helix Nebula, which is a planetary nebula, resulted from an explosion of a sun. All right, and all the energy that was contained in the sun was exploded and became a supernova. It can either become either a supernova or a black hole. A supernova or a black hole. All right, we must understand that, and you must and we know that as a result of what we call gravitational collapse. Gravitational collapse, or also under what we call gravitational singularity. All right, gravitational singularity, as we can see in cosmogony. Cosmogony is astronomy. Cosmogony refers to the study of the origin of particular astrophysical objects in our solar system. It is most commonly used in reference to the origin of the universe, the solar system, or the Earth-Moon system. The prevalent cosmological model of the early development of the universe is the Big Bang theory. As you can see displayed here, singularity. We know gravitational singularity. That's what it's called. Let's visit that. Wormhole, space-time, fourth dimension, all mean the same. Gravitational singularity, i.e. cosmogony, which you're supposed to know. Space-time singularity, or simply singularity, deals with gravity, all right? Is a condition in which gravity is predicted to be so intense that space-time itself will break down catastrophically. As such, a singularity is by definition no longer part of a regular space-time and cannot be determined where or when. Gravitational singularity exists at a junction between general relativity and quantum mechanics, i.e., general relativity and quantum mechanics. Therefore, the properties of a singularity cannot be described without the established theory of quantum gravity. Trying to find a complete and precise definition of singularity in the theory of general relativity, the current best theory of gravity remains a difficult problem. A singularity in general relativity can be defined by scalar invariant curvature becoming infinite, or better by geodesic being incomplete. All right. Gravitational singularities are mainly considered in context of general relativity, all right, i.e. gravity, where density will become infinite at the center of a black hole without corrections from quantum mechanics and within astrophysics and cosmology of the earliest state of the universe during the Big Bang, all right? We know Big Bang, a star resulted from an explosion of what they call a nebula. When the star explodes, it creates what, as we said, a planetary nebula. All right, and all that exists in it expanded out to the universe. Now we know that beyond that universe, there's what they call a voided space. It's called void space, or what they call dark matter. It's called dark matter that exists Before there was matter, there was empty space. It's called nothingness. It's called voidness. All right. And within that void, there exists ether. Ether allowed voidness to be. Let's get into it. Gravitational singularity. Big Bang. Science of cosmogony. The Big Bang events is a physical theory that describes how the universe expanded from an initial state of high density and temperature. All right? From high density and temperature. Various cosmological models of the Big Bang explain the evolution of observable universe for the earliest known periods through its subsequent large-scale form. The models offer a comprehensive explanation for a broad range of observed phenomena, including the abundance of light elements, cosmic microwave background, radiation, and large-scale structures. The overall uniformity of the universe, known as the flatness problem, is explained through cosmic inflation, a sudden and very rapid expansion of space during the earliest moments. However, physicists currently lack a widely accepted theory of quantum gravity that can successfully model the earliest conditions of the Big Bang. All right, that takes me here. What is gravity? We're talking about gravitational singularity, right? That's what we're talking about. Gravitational singularity. That results in how the Big Bang came to existence and everything that was created from that Big Bang, i.e., our universe. All right, our universe. In physics, gravity from Latin gravitas means weight. And make sure you see that. In physics, gravity from Latin gravitas means weight. It's a fundamental interaction which causes mutual attraction between all things that have mass. All right, all things that have mass, i.e., matter. Gravity is most accurately described by a general theory of relativity proposed by Albert Einstein, okay, which describes gravity is not as a force, but a curvature of space-time caused by an uneven distribution of mass and causing masses to move along geodesic lines. The most extreme example of this curvature of space-time is a black hole. All right, it's called a black hole, from which nothing, not even light, can escape. One past black hole, once past the black hole's event horizon. However, for most applications, gravity is well approximated by Newton's law of universal gravitation, which describes gravity as a force causing any two bodies to be attracted towards each other, electromagnetism, with magnitude proportional to the product of their masses and inversely proportional to the square of the distance between them. All right, proportional to the square distance between them. All right, we'll go here. Interstellar medium. Very, very, very important. We know interstellar means the space between stars. The space between stars. That's what it means. All right. What is the star? First, let's look at what a star is. For all those who don't know. A star life begins with the gravitational collapse, as I said earlier, of a gaseous planetary nebula or meteorological comprised of hydrogen, helium, and traces heavier elements. Its total mass mainly determines its evolution and eventual fate. A star shines for most of its active life due to the thermonuclear fusion of hydrogen into helium in its core. This process releases energy that traverses the star interior and radiates into outer space. All right? Into outer space. At the end of the star's lifetime, its core becomes a stellar remnant, a white dwarf, a neutron star, or if it's sufficiently massive, a black hole. So it can become a white dwarf, a neutron star, or a black hole. You know, a black hole is a result of a curvature, all right, in space and time, i.e., a collapse in gravitational pull, i.e., singularity. As we said, stars are a result of a collapse in gravitation. Our star life begins with the gravitational collapse of gaseous nebula. And we know, as we said, the Helix Nebula is a planetary nebula of gas. When that collapsed, when that star collapsed, it created this universe under what we call cosmogony. It created this universe where we're subject to this star, which is subject to the time clock it was given for its gravitational pull on the planetary that exists within this universe. I.e., we can either result in what we call a white dwarf, a neutron star, or a massive black hole. I.e., that's why these stars are moving. These triggering stars we just watched in the last video, which you go back to in a second, that's why they're missing, because the black hole, i.e., void of space. When you're void of space, that's antimatter, because we know it involves zero-point energy, i.e., special theory of relativity. Let's move forward. Where were we at? Gravitational collapse. Where was that in a second? Where was that in a second? Interstellar medium. Okay, interstellar medium, which is red on the interstellar medium. Where's that now? Interstellar medium. In astronomy, the interstellar medium is matter, is the matter and radiation that exists in space between the star system and galaxy. You hear that? Is the matter and radiation that exists in the space between star systems and galaxies. This matter, this matter includes gas and ionic, atomic, and molecular form, as well as dust and cosmic rays. It fills interstellar space and blends smooth into the surrounding intergalactic space. The energy that occupies the same volume in the form of electromagnetic radiation is the interstellar radiation field. I repeat, the energy that occupies that same volume in the form of electromagnetic radiation. So that means that involves 0 point energy, vacuum, or what we call matter. Vacuum will call matter because all matter is subject to what we call the gravitational pull, gravity. All right. Let me find it. Interstellar medium. That's what we're talking about. Right here. History of knowledge of interstellar space, which means the space between stars. The space between stars. The word interstellar between the stars was coined by Francis Bacon in the context of ancient theory of little sphere of fixed stars. Later in the 12th, 17th century, when the idea that stars were scattered through infinite space became popular, it was debated whether that space was a true vacuum, i.e., void of matter. Void of matter, or filled with a hypothetical fluid, sometimes called ether. So we're talking about interstellar space, i.e., space between stars, and we know stars when they explode, they can either explode, they become what they call planetary planetary nebulas. All right, every star at the end of its life is a result of a result of what they call a planetary nebula, as we discussed it. All right, and which results in what they call gravitational collapse. Gravitational collapse. Later in the 17th century, when the idea that stars were scattered through infinite space became popular, it was debated whether space was a true vacuum or filled with hypothetical fluid, sometimes called ether, as Rene Descartes' vortex theory of planetary motion. While vortex theory did not survive the success of Newton's physics, an invisible luminous spherical ether was reintroduced in the early 19th century as the medium to carry light waves. In 1862, a journalist wrote, "This influx occasions a thrill of vibratory motion in the ethers which fill the interstellar space." You hear that? Which fills the interstellar space. So this luminous spherical ether filled this interspace between the stars. All right? This space between the stars. And we know stars are, when they explode, as a result of a gravitational collapse. And we know that results in what we call a black hole, a vacuum. It's called a vacuum, absent of matter. So they call it luminous spherical ether. Luminous spherical ether, or ether, luminous spherical means light bearing, was the postulation medium for the propagation of light. It was invoked to explain the ability of an apparently wave-based light to propagate through empty space, a vacuum, sometimes something that waves should not be able to do. We know a vacuum is void of matter. Vacuum is void of matter. Okay? And based off what they say, the problem that they could understand is that this ether serve as what they say uh, uh, a pool for the planets to swim in. That's what they said. Ether was invented for the planets to swim in, to constitute electric atmospheres and magnetic influence via to convey sensations from one part of our body to another, and so on until all space had been filled 3 or 4 times over with ethers. The only ether which has survived is that which was invented by Houdini to explain the propagation of light through what they call a transmission medium. All right, through interstellar medium. And we know interstellar medium is luminous spurious ether. Once again, our interstellar medium is luminous spurious ether, that which fills that space, that empty space. All right? So let's end this and come back with part 2. See you in a second.